to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems most often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Mike Perham, the CEO of Contribsys, who built Faktory with a K, and my fellow Rubyists will likely know him as the creator of Sidekiq. Mike Perham, we're so glad to have you join us on Maintainable.
Thank you for having me, Robby.
So, given your experience in our industry, what do you believe are a few common traits that a software applications code base is being well maintained?
Maintenance is all about ease of change, in my opinion, or at least that's one big factor of it. And some things that give you the confidence to change things are a really good test suite. So you want to have all of your major and even lots of minor use cases tested in your software. And that way, if you do want to make a change, you're not breaking users, you're not breaking customers, that sort of thing. Because you never know, right? I mean, there's bugs hidden in every line of code. And without those tests to exercise various edge cases, you'll quickly grow wary of any attempt to change your system. So a code base is a huge thing. The other thing that makes things a lot more maintainable is a low dependency count. So every dependency you have, or I should say external dependency that's not under your control, you have to do some amount of work every time that dependency releases a new version. You have to verify it against your system that it doesn't break anything. And so that's why you see lots of production systems doing work to reduce their dependency count over time. So, and certainly I've written blog posts on that subject and found that to be the case in my maintenance of my products.
Nice. So how do you define technical debt?
Well, okay. So technical debt, I look at that as sort of making changes to your system without doing the extra work necessary to make change easy in the future. So if you are making changes to your system that pull in new dependencies, but you're not adding tests to exercise that dependency enough to verify it in the future, then you've added technical debt to your system so that you've made your system harder to change in the future. And that's where your debt comes in. Now you need, at some point in the future, you're going to have to add those test cases to get your system back into a state where it is easy to change.
That's a really good point there. The things I'm really curious about, when it comes to, you mentioned, having things that are easy to change in your application, and if you're writing tests around your dependencies, that's an important thing. How far into testing an external dependency library do you advocate for, given that you're assuming that own, say, library, or if you're working in Ruby on Rails, or like in the Ruby world, you maybe have a Ruby gem that has hopefully its own test suite. Where do you find that dividing line between the gem should test itself versus how you're integrating with that test?
Right. Good question. Beginning developers often make this mistake where I like to say that you should always test your own code, not the code of a library that you use. So any exercising of a dependency should come through the testing of your own code. So if you're using an ORM layer like Active Record, you shouldn't be specifically writing tests to verify inserts, updates, that sort of thing. But what you should be doing is writing tests that verify your own application logic. And by necessity, those tests will exercise the underlying database layer. So when I say that you are adding technical debt to your application by changing it, oftentimes that means you're adding features without adding tests for those features. And so if you do change a dependency, like let's say you change your ORM layer, by necessity, your application code will change, but that doesn't necessarily mean your tests will change radically. Sometimes tests will get into the implementation of a particular library, and there's not a lot you can do about that, but you try to minimize that where possible, or abstract it into some sort of test facade.
Nice. Yeah, I often see when teams get outdated, maybe they're not able to make some bigger upgrades for, say, the the programming language itself or like the framework they're using, like say if you're using Ruby on Rails, and there might be a couple of major versions behind because they're relying on external dependencies that are not compatible with the newer version at the versions that they're currently using. And they're kind of like, well, how do we go through this process of like, we need to upgrade our dependencies so that we can then work with this newer version of Ruby on Rails, but they like lack confidence in their own test suite, maybe because they're like, well, we do have tests and our tests are passing, but at the same time, we notice that there's like a larger change, or if you see a major bump in a dependency from like a release version from like V1 to V2 or something, you're like, you worry that there might be some underlying changes in the API for using the library or something, and that becomes like a problem that you're not really sure, well, how are we going to do this without breaking things? And do you work on the major upgrade version of the libraries first? And so I hear you there. Do you have any suggestions for developers that are kind of like if they're navigating that problem right now?
Yeah. When I moved to Portland, I took a job at an e-commerce company. And when I got there, essentially the system was on fire. Not literally, obviously, but figuratively. Every change went through one guy, and the system was just constantly breaking. And he was constantly deploying new fixes and breaking things. And it was because the test suite was utterly broken. Nobody ran the test suite anymore. So they hired me in part to bring a little bit of sanity to this whole system. And so literally the first thing I did on day one was just start to get that test suite running. And it took me about a week just to get those 1,000 tests that they had written, to get those tests running. And, it's a lot of low-hanging fruit oftentimes. You fix one minor bug and that fixes 500 of those 1,000 tests, right? Because oftentimes it's one thing that's blocking everything. But once I got that test suite running, and not a small percentage of the tests, I had to figure out what the application was actually trying to do and what the proper behavior was. Once I got everything settled down, though, then we could actually start to run the test suite before deploying to production, and that put out a lot of the fires. But that was also, as you say, critical for any time we wanted to bump Ruby or Rails. You absolutely have to have a test suite that is in the 70-80% code coverage before you can expect any sort of confidence in upgrading those sort of major versions. So get that test suite going. If you are doing a major or multiple major version bumps, and you don't have a test suite that's big, that has that much coverage, then it does behoove you as a team to put in the time to get some profiling enabled and look and see what tests that you could add that would add the most coverage to your system. And getting that coverage number up as high as possible, as quick as possible, will help a lot. Once you have a good test suite, then it's just a matter of going through the major version change logs for those libraries and reading through them and making sure that you understand what changed, so that when you do bump it and you see some behavior, that'll oftentimes give your mental model some sort of clue as to who the bad actor might be or where that bug might be located.
I think that's some great advice. And I've also been on that end when you're looking at that dependency file, like a gem file, and you're like, okay, we got 60 gems here. All right, here we go. And it's like, where do you start tackling all of that? And then it's a challenge, I think, for teams. I want to circle back to technical debt just for a moment. And what do you believe developers often get wrong when they're discussing technical debt with each other and or with like stakeholders?
Oh, gosh. I will say, going back to the dependency thing, I think developers underestimate how much work a dependency will push onto you down the line. So in the future, people just pull in Ruby gems, and you see Rails apps that have hundreds of gems in their gem file. And people don't understand that 2 or 3 years from now, when you want to bump Rails major versions, you may have half a dozen or a dozen gems that don't have any more active versions being maintained. And so they're just not compatible with Rails 6, Rails 7, Rails 8. And now you've got to go back and you've got to find some other gem that is maintained today that can replace it, will offer the same functionality. And so you're going to spend days or weeks trying to get your system in an upgradable state, versus if you had, rolled your own or upgraded more frequently so as to make that upgrade process less onerous. That would be a big help. So yeah, I think people will pull in a dependency without realizing how much work that's going to entail down the line.
Great. So for those that aren't familiar with you and your company, could you share how you've started and grown a business out of your open source project, Sidekiq? How did that come about?
Sure, of course. Well, I was a consultant about 10 years ago, working with a customer, or a client, I should say, that had a large background processing system. And they were using Rescue. And the way they had their system set up, it was incredibly inefficient. And I realized this. They were paying for dozens and dozens of machines, thousands of dollars a month, just to process some quite small number of jobs. And so I said, if I ever get the chance, I want to build a multi-threaded version of Rescue, because that was the core of the inefficiency, is they were starting up a new process for every single background job. And by moving to threads, you remove that overhead, that memory overhead of having a separate copy of the process for each job. So I started writing Sidekiq. And then, like I said, I moved up to Portland and started working for this e-commerce company, which actually worked out really nicely because the e-commerce company themselves needed a lot of background job work. When you do things like logistics and inventory management and all this sort of e-commerce and ERP work that happens behind the scenes in e-commerce, all that can go through background jobs and it fits really nicely. So as I scaled this company, I added bells and whistles to Sidekiq so as to scale Sidekiq's processing. And so the two mapped really well onto each other. That e-commerce company was effectively my alpha customer for new features and changes to Sidekiq. So I also knew that by starting Sidekiq, I was starting an open source project that could become quite popular and require a lot of work. I mean, we're talking thousands of hours of work over the course of several years. And I knew I didn't want to do that for free. Otherwise, I would burn out and I would simply abandon it. That would be the same story as hundreds of other open source developers in our community. So I started Sidekiq Pro as a closed source gem that worked on top of the open source Sidekiq gem and put a price tag on it and just started selling it and hoped that people would buy it. And it turned out that people did, slowly at first, but in ever increasing numbers as people got used to the idea of paying for software, which in the Ruby community was essentially unheard of. Whoever thinks of paying money for a Ruby gem. After about 18 months of Sidekiq Pro sales, my monthly income was more than my actual salary. That's when I realized, why am I working 40 hours a week for my boss when this side project that I'm doing out of love is paying me more money at this point? So that's when I said, let's make this my full-time job. And I quit the e-commerce company and incorporated contributed systems and started working on Sidekiq Pro. I've launched about 4 products in the last 5 years. Launched Sidekiq Enterprise, and then I launched a whole new background job system called Faktory, which is essentially equivalent to Sidekiq, but works with any programming language. So the Sidekiq family is specific to Ruby, but Faktory can work with any language. And so that way, I'm slowly bringing my background job religion or cult to every programming language out there.
That's awesome. So for those listening, for some perspective, back in 2018, my company, Planet Argon, we conducted a survey of the Ruby on Rails community. And when we asked what background job adapters their teams were using, 50% of respondents answered Sidekiq. So we're actually going to be doing that poll again this year because we do it every other year. And so I'm expecting the number to be that and or higher probably. So kudos to you, Mike, and for the work you're doing there. I think we haven't used Sidekiq Pro ourselves yet for some of our projects because some of the smaller types of projects we're working on. But I know a lot of people that, are constantly talking positively about it. And so I'm assuming with that business model, you're also providing some more hands-on support at times or guidance to those developers and maybe even with that enterprise level. So it's getting access to the gem and there's probably some additional, they get to have some access to you and your team.
Right. Yeah, the core value is in the features, the additional features that the commercial versions include. However, the commercial versions also include things like private email support. So if you have a problem with Sidekiq, your only option is to go onto Stack Overflow or to open a GitHub issue and talk about it publicly. If you are in the government or in a healthcare company or finance company who doesn't want to sort of air their dirty laundry, a lot of times they'll want to talk to me privately about issues that they may be having. Customers love that too. So that's an option. But yeah, like I said, the features are the main thing that people are paying for because it's all integrated into one package. You know, you get 4 or 5 features that people will find intriguing, if not useful.
Great. Well, we'll definitely include some links to both Faktory and Sidekiq for folks to check out. You know, my team, when I was preparing for this, my team wanted me to ask a few questions. They were curious if there were any anti-patterns that you've seen pop up quite often with how developers are using Sidekiq. And does anything come to mind that you could kind of share with the community?
One of the most popular anti-patterns I often see is people trying to schedule jobs over and over and over. Essentially, they're trying to use Sidekiq to make an endless loop, right? But instead of spawning a thread and just putting a loop in there, what they'll do is kick off a background job, which does some work and then reschedules itself, right? So the problem with that is if that reschedule fails, then essentially you've broken the loop. And now you don't know that. You have no monitoring that loop is continuing. So I always tell people that background jobs in general, and obviously Sidekiq as an implementation of background jobs, a background job is a business transaction that you're going to run. It's a unit of work for your business. And so a loop that does some polling or whatever, that's not a background job. That is more of like a piece of infrastructure that can create background jobs based on events. So if you want to do things like PubSub or monitoring of some system or polling of some system, then it's best to build that yourself or use some sort of framework that allows you to do that, whether it be something like Event Machine or, well, I'm sort of dating myself by saying Event Machine because I don't think that's best practice anymore, but there's a number of libraries and frameworks out there that allow you to build sort of event-driven event loops and that sort of thing.
In those types of scenarios, are people doing that as a way to kind of have some sort of automated regular schedule versus dating myself by bringing up like cron as an example? Like, we want this thing to run every 10 minutes unless it's still running type of scenario?
Yeah, I mean, that's one of them. There's a number of use cases here. Maybe they're actually polling a system for changes. And so they want to poll like every 10 seconds or something like that. There's any number of ways that people are sort of hacking systems together to talk to each other. But again, that's not exactly what Sidekiq is designed for. Sidekiq does provide APIs for sort of starting services on startup, right? Or spawning a thread on startup. And so you could spawn a thread that does a subscription on Redis, for instance, subscribes to a channel, and then listens for channel events. And then for each channel event maybe it creates a background job to process that event. That would be more a proper architecture of something like that. What you don't want is a background job that contacts Redis, says, hey, do you have any events? And then if it says no, then it goes to sleep for 10 seconds and then contacts it again. That starts to stray into that anti-pattern area that you were talking about.
Right. So those transactions need to kind of close and not stay open with the sleep or something in there.
Exactly.
That makes sense. I'm curious a little bit. I'm assuming like your products and your software probably has some level of technical debt and maintenance work that you have to work on. You know, given that it's an open source project and you have your private aspect to it, how does your team organize the maintenance work amongst yourselves with the open source community?
Well, I'll be frank with you. My team is me.
Okay.
And my cat, but the cat really doesn't do much on the technical side. I have, explicitly done work to minimize technical debt and dependencies in my system. I'll give you an example. I removed Sinatra as a dependency from Sidekiq a couple of years ago. Well, I should say someone did most of the work for me. There was somebody that contributed that break. And what we did was move Sidekiq, instead of using Sinatra for its web UI, it was built directly on top of the Rack gem. And then the reason we did that is because at the time, Sinatra was lagging well behind Rack and Rails. So Sinatra was stuck on Rack 1. Meanwhile, Rails 5 wanted to move on to Rack 2. So essentially, Sidekiq could not move onto Rails 5 because Sinatra was stuck on the older version of Rack. So that's a great example of sort of a dependency holding you back and there being a little technical debt there. Either you're going to force your customers to stay back, or you need to do the work on Sinatra's side to allow them to use Rack 2, which obviously was one potential solution. But I just decided to rip out the dependency altogether. At some point, once your system becomes stable, you know exactly what you need to do and what functionality you need to support. And so then it becomes a little bit easier to rip out that dependency and implement that underlying functionality yourself. And it turns out that that's essentially what we did. We had a full test suite that exercised all the pages, so we could rip out Sinatra, put in raw Rack instead, and then rerun the test suite and see that the pages are still rendering, that we're still seeing the same content, that sort of thing. So I forget the exact question that you were saying, but that's a good example where I did the work to remove a dependency so as to free Sidekiq and its downstream users from that lock that Sinatra had forced on us. Right.
That's helpful to kind of get some perspective on how ways that you're actively maintaining and reducing dependencies in your system so that you can, so that other frameworks and tools can stay up to date with Sidekiq as well. And so there's kind of like, they can kind of evolve and get upgraded together. You know, knowing that you're a team of one with open source contributors, do you have product backlogs that you're working on that are kind of private versus what's publicly available? How do you decide how to prioritize when you're going to work on improving and updating maintenance tasks versus just building out some new features for your pro and enterprise customers?
Right. So as a team of one, I've sort of decided that I want to stay a team of one as long as possible. And so for the last 5+ years, I have been a team of one. The one thing that I try to leverage as much as possible is the public. So I do all of my work in public. In fact, I actively try to get people who email me privately. I try to get them to open GitHub issues instead of keeping a conversation in private email. And the reason I do that is because the more that's public, the more that people can solve their own problem by going through those archives. And the more people that solve their own problem, the less that contact me and need private responses that take my time directly. So all of my roadmaps, all of my issues and upcoming features, those all go into GitHub issues that are public. My private repos that hold the source code for my commercial products, they have no issues at all in them. They will occasionally have a pull request if I create a pull request for myself, and I'll write up a pull request description, sometimes with sort of a to-do checklist, so that when I roll out a particular feature, I know the steps that I need to take to roll that out fully. Things like, merge the PR, update the wiki page, write a blog post about it, that sort of thing. But yeah, like I said, I try to keep everything as public as possible. And when you do that, you get people who scratch their own itch a lot more often. So things like removing that Sinatra dependency, I said that someone did about 90% of that work for me, which was wonderful. But they were scratching their own itch. They wanted to unblock Sidekiq so that they could upgrade. And so I benefited from that, he benefited from that, and the whole community benefited from that work. And that's why my commercial products are closed source, but they are merely a set of features that work on top of the open source core. And so anyone can build those features themselves as a third-party gem. My commercial Ruby products are just gems like anything else. So there's no reason why other people couldn't implement the same thing. The only thing stopping you is the fact that now you're going to have to maintain that thing and you're going to have to support it with your users.
We'll be back with our interview with Mike in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to thank you, yes, you, by the way, this is my first recording in 2020, so thank you so much for listening to Maintainable. If you're finding these discussions valuable, please consider sharing a link amongst your peers and writing a review on Apple Podcasts, Stitcher, or wherever else folks seem to be writing podcast reviews of. Maybe provide a link on Twitter to one of your favorite episodes, maybe this one. Also, if you know someone in the industry who I should be speaking with on Maintainable, shoot me an email to Robby with a Y at maintainable.fm. And now, back to our interview with Mike Perham. Out of curiosity, what was Faktory? What did you develop that in? What programming language?
Faktory is written in Go.
Okay. And so if you're jumping between Ruby and Go on a regular basis, I assume, have you noticed any differences in the patterns for how you're maintaining and or writing tests in those two different types of approaches to software development?
Ruby makes things really easy to modify. Obviously, I can just reopen a class and redefine a method. Bundler makes dependencies really easy to manage. All of that is a little bit harder at Go. That said, things like Go modules have been surprisingly easy to integrate and to use. But things like integrating commercial features into the Faktory core that is open source is noticeably harder in Go because Go is statically typed, because it is not flexible. But that said, I would consider myself fluent in Ruby and pretty fluent in Go, but I would not consider myself as strong in Go as I am in Ruby. Things like creating anonymous functions, I just don't do a lot in Go. And that's one tool that I probably should leverage more in building commercial features that layer on top of that open core. But yeah, it is definitely a different mindset.
Yeah, I was curious about that. Another one of my guests recently was talking about how they found themselves not leveraging, say, TDD quite the same way that they did when they worked with other object-oriented programming languages. And was kind of, as preparing for this conversation, I was just kind of curious if you've seen some similar things when it comes to, say, writing tests, for example.
Well, yeah, I mean, going back to what I said at the start, a test suite is vital no matter what your system. Go is statically typed, so the compiler gives you a bunch of errors if you have issues, but you still need that test suite to exercise all those features. And so when I do build those features, I always do it from a TDD point of view. So I will have tests that exercise, for instance, I recently implemented job batches in Faktory Enterprise. And so I had to build a whole test suite that creates, nested batches that has different edge cases exercised so that I could validate that functionality works. And even then, obviously you miss things here and there. So I've got a customer who's sort of alpha testing Faktory Enterprise now because it was just launched 2 weeks ago.
Oh, wow. Okay. And
so I've got one customer who is already exercising it in production, and he found a bug yesterday that I had to fix, a crashing bug. So I had to fix that. But so you miss things. But Go has some amazing tooling around the tests, around like the race detector is some amazing stuff. Vet and format are amazing tooling for maintaining your source code, maintaining clean source code, and finding those errors before they ship to production.
Yeah, thanks for kind of diving into the weeds there a bit with your perspective after working with those different types of programming languages. Just a couple of final questions. First, I want to get some advice from you for listeners. So I know that a lot of development teams are often faced with the following scenario. Let's say they're building out a set of new features that require code that has probably been needed by other teams. So they're weighing up 2 to 3 options. And I think this might be going. So you could build that code yourself, as you've touched on. You could opt to lean on an open source library or a dependency, or maybe even as a third option, you could purchase a paid for license for a library, perhaps for extra features or the commercial support that's offered with it. What advice can you offer those teams on how they might weigh up those types of options at the moment?
That's a tough one. I know that Baremetrics is one of my customers. They used to, maybe they still do, have a page called Build versus Buy, where they have a tool where you can sort of punch in a bunch of numbers and get estimates at sort of how much this is going to cost to maintain versus how much is it going to cost to build it yourself. I will say that, like time estimates, developers almost always underestimate how much it's going to cost to maintain it themselves. You not only have the hours that you spend maintaining and upgrading a particular thing that you built, but you also need to incorporate the opportunity cost of not building, features or various marketing things that might get you more customers, that might improve your system. That time that you spent maintaining is time that you're not spending improving. So that's just one thing to consider, to think about. But the notion of build versus buy is omnipresent in almost every technical decision you make. You need to think about long-term maintainability for sure. And what is the enterprise IT acronym is TCO, total cost of ownership. How much is this thing going to cost you in terms of fully loaded salaries of developers to support and maintain a piece of infrastructure that you build yourself?
My company, we work on a lot of existing code bases primarily, and we take over, work on Ruby on Rails applications that have been around for a while. I think quite often the business owners or people, like stakeholders, didn't really even realize what the total cost of just having this software that they built in the first place, let alone some dependencies, might cost long term, because they're like, oh, we need to, we have this specific problem we're trying to solve. We need to build a web app for this thing, and then it integrates. It's some glue between two different systems, and great, we're going to build this thing, and then our problem's solved. But then they're like 6 years later, like, why are we still spending so much money on maintaining this thing? And the question is like, well, what sort of process did you go through to evaluate whether you should build it in the first place? Is maybe there wasn't a tool that could glue those systems that you could pay for commercially at the moment, but I think when companies are building their own software products versus using a SaaS, it's the same sort of problem. When you get into the dependency level, it's maybe a little bit more micro level, but it's a very similar conversation. It's just, developers need to make some of those decisions. And sometimes they're making those decisions on behalf of the stakeholders that are leaning towards, we're going to rely on the developers to help make a educated guess and recommendation for how they approach that stuff. And so I think you see these libraries and it's free, but, to just add it to your gem file, Rails is free, but there's a cost to the time and energy of long-term maintenance there. And I think that seems like a complicated thing to try to wrap your head around the cost around that when you don't really know what the future of that application looks like too. So it's an interesting challenge.
One of the things I specifically keep in mind that I'm not sure how much other project owners try to do is sort of respect the time and attention of my users and my customers. So I always write very explicit upgrade notes and changelog so that for each version, you can see what changed, and I link to issues. That kind of detailed project history is super helpful when you're upgrading a gem. And oftentimes you'll go to a gem and they'll have a changelog and it won't have been updated for 2 years.
Yeah,
right.
Familiar with that.
And so they have nothing but, your Git commits. That's essentially it. And so part of the value of me working full-time on Sidekiq and Faktory is that I can maintain that sort of project history and those notes because I respect my users and my customers, and I want to make their upgrades as easy as possible. Part of buying my products is you are paying for a system that is not only well integrated, that comes with support, but also has that kind of attention to detail around future maintenance and upgrades to make your life as easy as possible.
I think that's great advice, whether you're contributing to, or if you built an open source project and want to make that easy for, your users, whether it's, if you have the time to do that, obviously those are important things. Maybe also as a note, if you, just from a personal experience, there's a lot of libraries that we've worked with that will remove older upgrade documentation because they think it's like outdated and like no one's going to need this. But sometimes there's these scenarios where we end up on a GitHub wiki and you're like, okay, so there's upgrade documentation for the last major release, but what about 3 or 4 releases ago? How do you get from there? Well, who would still be using that? Like there's companies that never made that switch and they're trying to figure it out. So that's some good advice there. So a couple quick last questions. What non-software development related book do you find yourself most often recommending to people in our industry?
Oh, wow. I mean, I'm your typical nerd. I don't stray far from the herd in this regard. I read a lot of science fiction. Right now, I'm reading 2 books. I'm reading a book called Rising, which is on the rising sea levels. It's a work of near nonfiction, I think is what it's called. It's sort of about the realities, but not in any particular. It's not telling any one person's particular story. And the other book I'm reading is a book on mechanical watches, which I've recently gotten into. Mechanical watches are fascinating because they run for days and without a single electron in sight. So it's kind of neat to get away from electrons and see hardware that runs on its own.
Nice. I might, I'll link to that book out of curiosity for myself as well and include that in the show notes. And where can listeners learn more about your projects online?
Well, I am at Twitter at GetAJobMike, and I'm on GitHub at mperham, and my blog is at mikeperham.com. So all of those will give you various links to various projects of mine and my various random musings.
Well, thank you so much. It's been such a delight having you on Maintainable, Mike.
Thanks for having me, Robby. Really, it's been great.